Section 1.5. We're going to be talking about angles again. We in section 1.4 we talked about what an angle was, how to label it, and all this other kind of thing. But we're just going to take this a step further with section 1.5. So let's do this. Let's draw an angle. What I'm going to do is I'm going to draw another angle inside of it. You've seen this before. That shouldn't be anything new. But I'm going to label these angles. I'm going to label this angle 1. I'm going to label this little one right here angle 2. Now notice, both of these angles all have the same vertex, right? Okay. And we have a name for these two angles right here, angle 1 and 2. Okay, we call them adjacent angles. Anybody know what adjacent means, just off the top of their head? Somebody said something was adjacent to something else. What would that mean? Not opposite, next to, right? It means next to it, okay? The word adjacent means next to something. So these are adjacent angles. Look at it. Angle 1 and angle 2, they're right next to each other. Okay, so that's what adjacent angles are. But it gets a little more specific than that. Here's a couple things they do. Number 1, they share the same vertex. The same vertex. Alright, so both angles have to share the same vertex. Look at it. They both angle 1 and angle 2 have that same vertex, don't they? So in order to be adjacent angles, they must share the same vertex, those two angles. They also have to share a common side. Share a common side. Alright, so these two things must be true in order to be adjacent angles. So they have to have a common vertex and they have to have a common side. Which one's the common side? Do they both share this side right here? Do they both share this side right here? They do? Angle 1 has this side? No, angle 1 doesn't have this side. Angle 2 doesn't have this side. But what about this one in the middle? Okay, it's not necessarily in the middle, but it's in between them. Alright, and they both. Look at angle 1. Angle 1 has this middle side, doesn't it? And angle 2 has this middle side right there. Alright, so both of these things are true. They share the same vertex and they share a common side. That's adjacent angles. Let me just give you a quick picture of what may not be adjacent angles. What if we did something like that? And we'll call this angle 3 and we'll call this angle 4. They look like they're right next to each other, don't they? Right? Here's angle 3, here's angle 4. Right? But look at it. Look at the two things right here. Do they share the same vertex? No, they don't. Okay, look. Angles 3 vertex is right here. Angles 4 vertex is right here. They don't have the same exact vertex. So right away, we know they're not adjacent angles. All right? Writing this down, Freddie? Okay. They also have to share a common side. Now look, you might think they share a common side. I mean, they kind of do, because look, angle 4 has this part of it, but it doesn't have that whole entire side that angle 3 has, does it? It just shares a part of it. So both of these things are not true. So these are not adjacent angles. These would be right here. These would be adjacent angles. Everybody okay with that? Because we're going to refer to that every once in a while. Every once in a while we're going to say, look at those adjacent angles. You need to know what I'm talking about. So we have to define it. We have to explain what adjacent angles are. Because in the future, a lot of this stuff, we're just setting ourselves up for what we're going to do later on. And that's what one of these things is right here. It's just kind of setting us up for what we're going to do a little bit later. All right? Let's do another one. I don't have my book in front of me. I forget the order that I went in. Let's see. I did adjacent angles, and then I did... let me look. All right, I had to look in the book and look. So this is what we have right here. This is actually probably familiar to you. You've probably seen something like this before. And we'll call this angle 1, we'll call this angle 2. First of all, what's true that you just learned about 5 seconds ago about angle 1 and 2? They're adjacent angles, aren't they? Look, they share the same vertex, don't they? All right, you see it? And they share a common side, agreed? So yeah, so those right there, they are adjacent angles. All right, but they're a little bit more than that. Look at angle 1 and angle 2. If I added them together, angle 1 plus angle 2, how many degrees am I going to get if I add those two angles together? I'll get a straight line, which is how many degrees? 180 degrees, that's right. And it forms a straight line, exactly right. That's what I want you to see. We'll talk about this right here in a few minutes, okay? Angle 1 plus angle 2 being 180. But I also want you to see this, that they form a straight line. There are two angles, not 3, not 4, not 5, but there's two angles that form a straight line. And we call that a linear pair. Linear pair. Why do you think we use the word pair? Because there's two of them. That's right. Because a pair is two, right? So there's two of them. There's angle 1, there's angle 2. There's two of them. What about that word linear? What geometry word is inside that word linear? Line. Okay, so if there are two angles that form one line. Write that down. I'm not going to write it down. You write it down. Two angles that form one line. That's a linear pair. Make sense? Two angles that form one line. That's a linear pair. All right? Calvin, you getting all this? Come on, get your head up, please. Just write it down. Write this stuff down. You should be writing. If you're writing, you'll stay awake. All right? That's how it works. So that's a linear pair. And they do add up to 180 degrees. All right? Now, what if I did this? What if I said, here's an angle right here, and here's another angle right here, like this. What if I said that this was 50 degrees, and let's say this was 130 degrees? All right? Now, what's true about 50 and 130? What do they add up to be? 180. But are these two angles right here, are those two angles linear pair? No, they're not, okay? Because they don't form what? A straight line. They don't form just one single line. Now, they do add up to 180 degrees, don't they? All right? But they don't form, those two angles right there don't form one straight line. All right? So I don't consider them a linear pair. What about angle 1 and angle 2, though? Those are two angles that do what? They form a nice straight line. Okay? So they would be a linear pair. So if I ask you what a linear pair is, if I say name the linear pair in this picture right here, what would you say? What would your answer be? Now, don't say 1 and 2. Angle 1, right, and what?
2.
Angle 2. All right? So put the symbol in front of it. It's angle 1 and angle 2. So if I said name the linear pair, you're giving me two angles. Two angles that do what? Form a straight line. That's right. Okay? Everybody with me on that? Okay, good enough. Let's go to something else. What if I had two lines that they intersect each other? Now, I didn't sit there and figure out exactly how I'm going to draw these. I just made two lines that intersect each other. No big deal, okay? There was nothing special about how I angled them or anything like that. They're two lines that intersect. I've got several angles formed here then, don't I? Look, I've got angle 1. We'll call this 2, 3, and 4. You see those 4 angles? But what I want you to do, I want you to see a relationship between a couple of these angles. Look at the angles that are opposite each other. Now, that's not the word that we're going to use. They have a little different word. But look at the ones that are opposite. For instance, angle 1. What would you say is the opposite angle to angle 1? Angle 3. That's right, because 1 and 3 just either kind of like mirror images of each other, right? They're opposite of each other. Now, 1 and 2 wouldn't be opposite. What would 1 and 2 be? You actually have two choices. You could say they're a linear pair, or you could say they're adjacent. Right, you got actually two different answers for that, can't you? Don't you? But 1 and 3, what are 1 and 3? They're opposite each other, but we don't use the word opposite. It would be kind of nice if they used the word opposite, but I've never seen a geometry book use the word opposite for this. They always say they're vertical angles. So I'll use the symbol for angles. Vertical angles. Now, that doesn't mean just because they're up and down. Okay, we think of vertical lines going up and down, don't we? It has nothing to do with that. Okay, I'm not sure where they got the word vertical to describe these, but that's what they did. So we call them vertical angles. Any angles that are opposite each other, but you got to have two lines. Two lines form two pair of vertical angles. So if I said, name the vertical angles. The vertical, I'll shorthand that. Okay, so here's the problem. Name the vertical angles right here. And there's actually two pair of vertical angles, aren't there? Okay, yeah, so angle 1, I'll put a comma to separate them, and angle 3. So that would be one pair of vertical angles. What's the other pair of vertical angles? Yeah, 2 and 4. 4 and 2. Doesn't matter what order you put it in. I'll go angle 2, angle 4. And that's the kind of stuff that they could ask you, all right? They could say, name the vertical angles. Now, the pictures might be a little more complicated than this, but this is the basic idea. The angles that are opposite each other. Do you see that? They're opposite each other. And these right here are opposite each other. They're the vertical angles. All right? I'll throw this in free of charge. They don't really talk about this in this lesson. We'll talk about this in another lesson. But what do you think might be true about these vertical angles, 1 and 3? As far as the measure of the angle. Yeah, they look equal to each other, don't they? Yeah, look at that angle 1 right there and this angle 3 right here. They look like they're the same angle, right? They're both obtuse angles, and they look like they have the same measurement, and they absolutely do. All right, so that is something that's true about vertical angles. The vertical angles are always equal to each other. Now, we'll deal with that in another, I think another chapter. I don't even think we do that in this chapter. But you will learn that at some point, that vertical angles are equal to each other. So 1 and 3 must be equal. What else must be equal here? 4 and 2. All right? So that's something, and I know I say this all the time, but it's true. I say it because it's true, that we're going to use this a lot all year, okay, the vertical angle thing. Knowing that they're equal to each other, that's going to be very, very, very helpful to us all throughout the year. So it's good that you remember it right there. All right? All right, let's do some more. This goes back, and it kind of looks like that linear pair thing, but it's just another way to discuss it. Actually, let's have it go the other side, make it look a little bit different. Okay. Now watch this. What if I said that this angle right there was 30 degrees? It's probably a little more, but let's just say it's 30 degrees. Remember what we talked about earlier about these two angles? They're linear pair, they're adjacent to each other, but they do what? They add up to 180. So if this was 30 degrees, somebody tell me what this big obtuse angle would be equal to if this was 30 degrees. It's 150. How'd you get 150 out of that? What math did you do, Anthony? 30 plus? Yeah, but you didn't know this was 150. Guys, listen up. Hey. 180 minus 30, right. Okay? So the math in order to do this, I mean, you actually did it in your head without thinking about exactly what you were subtracting. All right? But what did you do in your head? You actually did this. Watch, this is your brain right there. Okay? In your brain, you did what? 180. Talk to me. What'd you do in your head? Minus 30, didn't you? Yes. So you did 180 minus 30, which is 150. Everybody with me on this? I want you to start thinking a little bit. All right? Don't just sit there and just let me talk. Okay? Think about what I'm saying. Guys. Think about what I'm saying and try to follow along here. Don't just let me talk. Sean, you got nothing on your desk. I've asked about 5 times this class period. Look it up on the YouTube, okay? It's for everybody to take notes, and you don't have anything on your desk whatsoever. No. I discussed that already, too. Look it up. I'm getting really ticked off right here. Okay? I've asked you to do something. I expect you to do it. Okay? Don't tell me I'm going to watch it tonight. I already had that discussion earlier. That's what I'm talking about. It's making me mad. So look at this. What if, let's just do this very quickly. What if this was 40? What would this angle be? It'd be 140, wouldn't it? Because what'd you do? You went 180 minus what? 40 this time. What if this was 50? What if that was, did I already do that? No. What if that was 50? What would this angle be? It'd be 130. What did you do every single time? You went 180 minus whatever that angle is, right? Now watch this. Let's think a little bit. What if this angle was x degrees? You didn't know how many degrees it was. That's what the x means, okay? It means an unknown value. I don't know how many degrees this is, but I wanted to figure out what this angle was. You know, well, I can't figure that out unless I knew this. But how would we write it? What do we do in our head? Very good. That's what I wanted to hear. Exactly right. Look, if I know this to be x, how do I find this? What did you do in your head? You went 180 what? Minus whatever that other angle was, right? So this angle right here is going to be 180 minus x. Tomorrow we're going to continue with this because we're running out of time today. But tomorrow we're going to continue with this, and we're going to do some stuff. We're going to do a couple little word problems where you're going to use this word. Now watch real quick. Do you see how these two angles, remember this was 50 and this was 130? What did they do? They added up every single time to be what? 180. Anytime you have two angles that add up to be 180, we call them, write this down, we call them supplementary angles. All right, supplementary angles if two angles add up to be 180 degrees. They don't have to be adjacent to each other. Do you remember when we had those two angles right here? They're not a linear pair and they're not adjacent. But 50 and 130 do what? They add up to 180. So what's true about these two angles right here? They are supplementary. That's right. So they don't have to form a straight line to be supplementary. Okay, but they do have to add up to 180. All right, does that make sense? All right, I'm going to give you a worksheet today. Do as much as you possibly can on the worksheet. We're going to finish it up tomorrow, and then I'll let you finish that worksheet tomorrow.